Hi, welcome to Physics Demystified. This time it's Resultant Forces, Chapter 1, Video 5. Now, if the resultant force on a body is zero, it will remain stationary or continue to move at the same speed in the same direction. If the resultant force on a body is not zero, it will accelerate in the direction of the resultant force. Now, acceleration is always caused by a resultant force. The acceleration can be calculated as follows. Force is equal to mass multiplied by acceleration. F equals ma. The unit of force is of course the Newton. For example, a 2 kilogram toy car is pushed so it accelerates at 0.5 meters per second squared. What is the force acting on it? Well, F equals ma as we said, so F equals 2 times 0.5, which equals 1 Newton. Now, brief word about terminal velocity. Now, think of a falling skydiver. A falling skydiver experiences a force called weight that acts towards the centre of the Earth. Now, the weight is equal to the mass multiplied by the gravitational field strength, G. On Earth, G is about 10 newtons per kilogram. Now, initially, the weight is the only force acting on the skydiver. As the skydiver falls, friction with the air particles increases. This is called air resistance or drag. This opposes the force due to gravity. Now, these two forces combine to produce a resultant force in a downward direction. The skydiver accelerates, and the acceleration produces increased velocity. That's what acceleration is, and the increased velocity produces more drag in turn. Now, the acceleration continues to increase velocity and hence drag. Eventually, the drag becomes equal in magnitude to the weight. So now the skydiver has reached terminal velocity, which is maximum velocity. It's the maximum velocity he can go to. He can't go any faster. The skydiver continues to fall with constant velocity. There is no further acceleration. The forces are balanced. We say the skydiver is in equilibrium and the resultant force is zero. An object with greater surface area or less streamlined shape has greater drag. So when the skydiver opens his or her parachute, the force of drag on them increases, and this causes them to decelerate to a much lower terminal velocity. This graph shows how the velocity of a skydiver changes as they fall. The skydiver accelerates as they fall until they reach a maximum velocity, the terminal velocity. They then open their parachute. Now, this is going to cause a large deceleration before they reach a much lower new terminal velocity. They then land and their velocity is zero. Now, when there's no atmosphere, such as in space, there is no air resistance. Parachutes do not work on the moon. Forces for circular motion. An object moving in a circle is accelerating due to its changing direction. Now, the resultant force that causes the acceleration acts towards the centre of the circle. For a mass on a string, this force is provided by the tension in the string. For an orbiting planet or satellite, this force is provided by the gravitational pull on the planet. Now, the centripetal force needed to make a body perform circular motion increases as the mass of the body increases, the speed of the body increases, and the radius of the circle decreases. In summary, force is mass times acceleration. Weight is mass times the gravitational field strength. And when the drag of a falling object equals its weight, it is at terminal velocity. This means it will continue to fall at a constant velocity. Drag is affected by how streamlined an object is, and the centripetal force of an object is dependent upon the mass of the object, the speed of the object, and the size of its orbit. Okay, that's it for forces and motion. Next time we're going to be looking at momentum and stopping. So make sure you subscribe to our channel and click the bell to receive updates as and when we upload more videos. Until then, keep wondering about the universe.